Hi, my name is Sam Drake. I'm an architect in Oracle TimesTen in-memory database development. I'm going to talk to you today about the architecture and concepts for TimesTen Scaleout. Now, I've said a couple of times now that a grid can be configured to keep more than one copy of data, right? And that certainly is what we would encourage production customers to do, right? If you keep two copies of your data, then you have high availability and fault tolerance. If one host goes down, that's okay, everything keeps running. And we call that K safety. A grid can be configured to keep K copies of data. In this release, K is either 1 or 2. You define the value of K when you create a grid, not when you create a database, when you create the grid. And of course, setting K equals 2 provides fault tolerance and improves availability. You could use a K equals 1 database for testing or experimentation. Maybe it would be appropriate in environments where you're not too concerned about high availability, but we expect the vast majority of production customers will use K equals 2. Now, I've said a couple of times now that for a hash distributed table, we'll make sure that a particular row is stored in either 1 or 2 elements. What really happens is that a particular hash value will be stored in exactly one replica set. Now, a replica set is a set of elements of a database that contain the exact same data. So if you have a K equals 1 database, then a replica set contains 1 element. If you have a K equals 2 database, then a replica set contains 2 elements. And those elements in the replica set contain exactly the same data at all times. Both elements are active, meaning that you can execute DML, you can do inserts, updates, and deletes initiated from either element in the replica set. They're both read-write. You can change them both simultaneously without limitation. It's not an active standby pair, as you might be thinking if coming from TimesTen Classic. We use two-phase commit protocols to keep those 2 elements in the replica set in sync, and as well as to keep changes in different replica sets in sync if a particular transaction changes more than one replica set. It's not replication. We change both elements synchronously, basically. And TimesTen itself will create replica sets. When you create a database in the grid, and we'll talk more about how this works in a minute, but when you create a database in the grid, we will automatically create an element of each database in each data instance, and we will automatically connect 2 of those elements together into a replica set. Now, replica sets are an important part of our fault tolerance strategy in TimesTen Grid. Suppose you have, again, this environment here where we have 2 replica sets, each with 2 elements. If any one of those elements goes down, everything keeps running. There's no problem at all. Applications keep running, all the data is available. Really nothing much goes wrong if one element goes down. Now, suppose 2 elements go down. Well, it kind of depends on which 2. In this case, we have element 1 and element 4 have both gone down. They're in different replica sets. And so in this case, everything keeps running, right? Because all the data is available. The data from replica set 1 is available because element 2 is up. The data from replica set 2 is available because element 3 is up. So everything keeps running with very little disruption. If element 1 comes back up, when the host on which element 1 resides is rebooted and that instance comes up, we will automatically resynchronize the data in element 1 from the data in element 2, so they will be kept in lockstep at all times. So my key message here is, if you have multiple failures in different replica sets, then you don't lose data or functionality. Everything keeps running. On the other hand, suppose you have 2 instances go down, 2 elements go down, and they are in the same replica set. Well, now you have a problem, right? Because both copies of the data that are stored in replica set 1 are unavailable. Well, what happens then? Well, if your application is modifying data that's stored in other replica sets, suppose you want to modify data for customer 2, which is stored in replica set 2, that's okay. That SQL runs just fine. If you try to update data that is stored in replica set 1 or try to query data that's stored in replica set 1, your application will get an error. And if you're trying to execute SQL which touches all data, suppose you want to do a count star on this table, right? You'll get an error. Now there is a SQL hint that you can specify in your SQL that will say that's okay if they're in this case just do the best you can and give me the partial results for just the replica sets that are up and available at the moment. But by default, in this scenario, some data is unavailable and your applications will see some disruption, although data that's not in the failed replica set continues to be available. So how the system responds to multiple failures depends really on where the failures are, right? If the failures are in different replica sets, then that's really not much of a problem at all. But if all the elements in a particular replica set go down, then some data is unavailable. So ideally, to do that, we want to minimize that from happening. We would like to make sure that it's very rare for both copies of data in a single replica set to go down simultaneously. Think about the scenario I talked about earlier, where you might have 2 racks full of hosts all running TimesTen data instances, and those racks are connected together by a network. If you think about the way the power supplies work, it's more likely that an entire rack of machines is going to go down at once than that both racks are going to go down, right? If rack 1 is plugged into the wall into a power supply and rack 2 is plugged into the wall in a different plug using a different power supply, if somebody's walking around and they trip over the power cord, one whole rack is going to go down, but the other rack's going to keep running. And so to give users the ability to address this and to make sure that we distribute data in an appropriate manner, TimesTen Grid supports what we call data space groups. When you define a host in a grid, you have to tell us which data space group that host resides in. Is it in data space group 1 or data space group 2 for a k=2 grid? The assumption is that all of the hosts in a particular data space have a lot of things in common and are likely to fail together. So, for example, data space 1 might be a rack and data space 2 might be a different rack. In a cloud environment, data space group 1 might be hosts in one availability zone, and data space group 2 might be hosts in a different availability zone. The idea is if something catastrophic happens, all the hosts in one data space are going to go down at once, but it's much less likely that something will take down hosts in different data spaces simultaneously. Once you've defined these data space groups, then TimesTen makes sure that every replica set consists of an element on an instance on a host in data space group 1 and an element on an instance on a host in data space group 2. That makes sure that there is as much physical separation between the elements in a single replica set as possible, making it as unlikely as possible that both copies of data in a particular replica set will go down simultaneously. If a user does an appropriate job of assigning their hosts to data space groups based on these physical characteristics, they can go a long way towards minimizing the possibility that both copies of data for a particular replica set go down simultaneously. So as a summary, let's talk about the terminology we've used so far, and let's just make sure that we're all on the same page about it. So a host is a physical or virtual machine. An installation is an untarred copy of the TimesTen distribution. It's completely read-only, never changed. An instance is a running copy of the TimesTen software, which is created from an installation. There are 2 types of instances: data instances and management instances. Data instances manage some of the data in databases. Management instances manage the grid itself. A database, well, you know what a database is. It's a named collection of users and tables and sequences and rows and all of that, just like in any database software. An element is the portion of a database that is stored and managed by a particular data instance. Under the covers, it has checkpoint files and log files, etc. It also has all of the schema for the database of which it is a part. A replica set is a pair of elements which contain exactly the same data. And a data space group is a set of hosts that share the same physical resources, with the idea being that the hosts in a single data space group are more likely to go down simultaneously because they share those physical resources. So I think those are the terms we've introduced so far, and if you don't remember the details, that's okay. But these are the terminology. This is the terminology that we're going to describe a lot of the rest of this software in terms of.